This video is about a semipinacol rearrangement that I once used in a test. To be honest, it turned out that this was a pretty hard question. So now I only use this particular question as an example question. And this is actually an example of a very hard question. If you want to try this question before seeing the answer, read the information provided in the question carefully and then look at the reactants. Now pause the video while you try to find the answer. Let's have a look at the reaction and the information that the question provides. The first thing to notice is that the question states that this is a semipinacol rearrangement. In a semipinacol rearrangement, you need to have a hydroxyl functional group one carbon bond away from a carbocation. This means that you also need a group that easily leads to a carbocation. You can see that in the starting material here. We have one hydroxyl, we have an hydroxyl, and we have an epoxide. And this epoxide can be opened using the zinc dibromide to form a carbocation over here, or here. But the tertiary carbocation that forms here is much more stable than the primary carbocation that would form here. So the tertiary carbocation is the one that forms. Moreover, the carbocation here is in the right location relative to the hydroxyl, so we're off to a good start. As I said, the pinacol rearrangement involves a hydroxyl next to a carbocation. And in the reaction, the pair of electrons on the oxygen moves towards the adjacent carbon atom to form a carbon-oxygen double bond. To avoid the formation of a pentavalent carbon over here, one of the electron pairs corresponding to a bond to this carbon needs to move onto the carbocation. For this reaction, I had to give the hint that the reaction involves a hydride shift. The reason that I had to give this hint is because you have probably seen lots of examples where the electrons in a carbon-carbon bond move. So you would expect this carbon-carbon bond to move. So you can see that none of the given answers involve that carbon-carbon bond moving. So knowing that there is a hydride shift, you should then realize that you need to consider moving the hydride over. When the hydride shifts, you form a ketone over here. Answer A has the ketone in the wrong place, and that one is now out. You also see that as a result of the hydride shift here, the ring size doesn't change. Here you have a change in the ring size, so answer B is out as well. If you then look at product C, you see that product C is the right answer. So on the next slide, I will now go in a bit more detail on how you would draw the reaction mechanism. So we are going to use our zinc dibromide, and I'm going to show this as this particular cation over here. A lone pair on the oxygen will interact with a positive charge, and that will lead to the formation of the tertiary carbocation. Just a second while I copy the rest of the molecule. So I have my O minus forming a complex with my positive ZnBr over here, and I now have a positive charge over here. So here I have my OH, and as I was saying at the start of this video, the electrons from the oxygen are going to move here, and I now have to decide which one of these bonds is going to move. So, and I have a hydrogen here as well. Now the question says that it's a hydride shift, and that is how I know that this hydride moves here. and that gives me and there's another hydrogen and a methyl group over here. So you might say, oh, but I went from a carbocation to well, a zwitterion and a carbocation, 1+ overall charge, and that is because I haven't, according to my curly arrows, lost the proton over here. Now if I do a workup with some PT proton transfers, you can see that this hydroxyl is going to get protonated, the ketone is going to get deprotonated, and my overall product therefore becomes this compound. Sorry, that last one wasn't indicated as a proton over there. And you can see that that is indeed answer C. So answer C is the right answer. So I hope that you found the video helpful and that you now see how this reaction works, but also how important it is to read the information in the question together with an understanding of the molecular structures. Thank you and see you in the next video.